All right. Today we are going to talk about complex numbers. Complex numbers. Are based on a number whose square is -1. And complex numbers deal with an imaginary unit. And we're going to say that the imaginary unit I, this lowercase cursive I, is the complex number whose square is -1. So I squared equals -1. And I is equal to the square root of -1. All right, so a key concept, we can say that if the square root of -a is equal to the square root of -1 times the square root of a, then since I is equal to the square root of -1, we can replace this square root of -1 with an I, and we put it right next to the radical a. All right, so these complex numbers, this imaginary unit, is a way of continuing an equation and continuing to solve a quadratic when you end up with a negative under the radical sign. In the past, when you've had a negative under the radical sign, you've gone to no real solutions. All right, and now as you progress, the word in there, no real solutions, okay, when you had a negative under the radical, well, now you have the ability to find imaginary solutions by using an imaginary unit, which is I. Okay, so the way that this works and the way that you'll use it today, is you'll be asked to simplify using I. So if you're given something like the square root of -18, all right, the first thing you do is you pull the negative out of here. Here's what I mean by that. The square root of -18 is equal to the square root of -1 times the square root of 18. Okay? Well, since the square root of negative 1 is equal to I, we can replace the square root of negative 1 with an I. And since the square root of 18 is equal to the square root of 9 times the square root of 2, we can replace the square root of 9 with a 3. So what we're left with in this case is 3i radical 2. And that's how you would write the square root of negative 18 using I. On a much simpler scale, if you had to write the square root of negative 7 using I, that's equal to the square root of negative 1 times the square root of 7. The square root of negative 1 is I. The square root of 7 is already in simplest form, so we simplify this as I radical 7. Square root of negative 12 is equal to the square root of negative 1 times 12 has a perfect square in it. 12 is the square root of 4 times the square root of 3. So the square root of negative 1, it's equal to I. The square root of 4, that's equal to 2. And the square root of 3 is in simplest form, so we leave it alone. So now when we clean this up and we rewrite it, the real number goes first. So we get 2i radical 3. And that is simplified using I. Making a little bit of sense? Square root of negative 25. That's the square root of negative 1 times the square root of 25. The square root of negative 1 is equal to I. The square root of 25 is equal to 5. And then we rewrite that with the real number first, then the I. So the square root of negative 25 is equal to 5i. Let's do one more here. Square root of negative 24. That would be equal to the square root of negative 1 times square root of 24. Largest perfect square that goes into 24 evenly. All right, that would be the square root of 4 times the square root of 6. So then we replace the square root of negative 1 with I. We replace the square root of 4 with 2. The square root of 6 is in simplest form. So then we just finish this up as 2i radical 6. That is your simplest form using I. All right, and then the second part of today's assignment. An imaginary number can be written in the form A plus BI. And today what you're going to be doing is graphing these imaginary numbers. All right, so an imaginary number can be written in the form of A plus BI. We refer to the A as the real part of the number. And then we refer to the BI, or anything in that form, as the imaginary part of the number. So when graphing an imaginary number, we still use a coordinate plane. But the x-axis is now called the real axis. And the y-axis, the vertical portion, is referred to as the imaginary. The imaginary axis. So in the second part of your assignment today, you're going to be asked, let's see what the wording is. Plot each number and find its absolute value. So we're going to work on the plotting part of each number today. So if we're going to plot -5 plus 3i, the -5 is the real part. So look, on this real axis, we go to -5. 1, 2, 3, 4. Here's -5. On this imaginary axis, we're going to go to +3i. So 1, 2. This is your +3i. So when we plot -5 plus 3i, it's right here. That's the graph of -5 plus 3i. All right, the horizontal portion corresponds to the real portion. The vertical axis corresponds to the imaginary portion. Okay? And then if you're asked to find the absolute value, well, the absolute value of -5 plus 3i is equal to the square root of the -5 squared plus the real portion of the imaginary number, 3 squared. And that would be equal to the square root of -5 squared is 25, and 3 squared is 9. So the absolute value of -5 plus 3i would be equal to the square root of 34. All right, so if we're going to graph and find the absolute value of, let's go with 5 minus 2i. All right, 5 minus 2y, we draw our coordinate plane. All right, the 5 is the real part, so we go out to 1, 2, 3, 4, 5 on the real portion. On the imaginary axis, we go to -2i. So that would be -1, -2i would be right here. So here's the point that corresponds to 5 minus 2i. The absolute value of 5 minus 2i is going to be equal to the square root of 5 squared plus -2 squared, which would be equal to the square root of 25 plus -2 squared is 4, and that would be the square root of 29. All right, and let's take a look at one more. Let's plot and find the absolute value of, I'm going to try red ink so I don't have to draw this coordinate plane again. 1 plus 4i. All right, 1 plus 4i, we go to +1 on the real axis. And then we would go up here to, now I'll just redraw it. All right, so we're going to plot 1 plus 4i, and then we're going to find the absolute value of it. So on the real axis, we go to +1. On the imaginary axis, +4i. So 1, 2, 3, 4. Here's our point, 1 plus 4i. And then if we have to find the absolute value of it, the absolute value of 1 plus 4i is going to be equal to the square root of the real portion squared plus the number in front of the imaginary number squared. So in this case, 4 squared. So we get the square root of 1 plus 16, which is the square root of 17. So plotted version on the coordinate plane, absolute value version by squaring the real and then adding it to the square of the number in front of the imaginary unit. All right, does anybody have any questions? All right, then we got page 253 today. 1 and 2, and then 6 through 17. Let me finish what I'm doing.